Hello everybody, welcome to episode 2 of Java Basics. Today I'm going to be going over a little more, I wouldn't say advanced concepts, but definitely builds on the elementary stuff I taught you guys last lesson. We're going to be going over modifiers, Boolean logic, if statements, switch cases, basic string methods, and I took some advice from you guys last time, and this video, there's going to be problems that I have up on the GitHub. Then I'll pause the video and tell you guys when to work on them, and also a big project, well, not big, a small project at the end that you guys can work on over the weekend. So let's get right into it. Immediately, I'm going to say that I believe I forgot to mention something last time, and that is commenting code. So there are two parts to coding, the two types of text. There's one that is this multicolored blue, kind of like turquoise and like light blue colors, and you'll find a bunch of other ones that throw strings and things. But then there is this consistent green color that you can see all over here, and this is like not syntax at all, as you can tell, because like this up here, this is what code looks like. But then you go down here, this is just English. I'm just typing out in English. The reason I can do that is because I do something called commenting, and I comment by typing in these two double forward slashes, and then I follow that by a line of whatever I want. And the Java compiler, which looks for, like we talked about last time, the language of Java, will skip over that and say, this doesn't concern me, this isn't Java, this is English, so I'm going to skip over it. And it allows you to type in whatever you want, so you can make notes to yourself within code instead of like on a notepad somewhere else. So, for example, if I wanted to add a comment saying, this is a comment, I would do // and then it turns into a comment. I can type in, this is a comment. Now, say I want to have multiple lines. If I press enter, it'll go back into code. So what I can do is I can type / asterisk, and then click enter, and then type asterisk / like almost like two brackets, but for commenting. Now, whatever I type in here is going to be all comments instead of code. So that's pretty useful, and I use it all the time to lay out like what I'm going to do in the code, as well as set something called to-dos, which are pretty cool. Maybe I'll show you guys those later, but basically it's like little points that you can come back to in the code, and it'll tell you what you're missing, and that's for like IntelliJ, so we won't get into that right now. But all right, why don't we start off with the first concept that I wanted to teach today, which is something called scopes. So the idea of a scope will be built upon later, but basically what you guys need to know for now is that when I have these brackets, you can see one up here and one all the way down here. Any variables, any primitives that I declare within those brackets will be accessible by anything inside the brackets, but it won't be accessible by anything outside the brackets, unless there are some changes to that through like object instantiation, but we will get into that later. But if you declare a variable within brackets, you cannot immediately access it outside those brackets unless you do something funky, which Mustafa is teaching you guys in object-oriented programming. So what is a scope? You should be able to define it. It is the set of brackets in which a code piece is accessible without using something called object-oriented programming, which Mustafa will teach you later. So now let's go into modifiers. So what is a modifier? Last time, as you know, with the prints and primitive, we just declared, oh, here's a Boolean, here's a double, here's a float, here's a char. But as you can see here, I start typing some funky words which pop up in like dark blue. So what are these exactly? So these are called modifiers, and they basically change how you are able to access the variable. So if I make a variable public, anything can access it. And I mean anything basically. Another package can access it, another file can access it, and I can prove that to you because here I have a variable defined in this file, right? Modifiers and Boolean logic. I made an integer called everyone can see, and I set it equal to 0. So now if I go into this file, and I go to the very bottom, and I type in the name of the class, modifiers and Boolean logic, so now I have basically a representation of the class here as a template, and if I press dot, I can actually access the everyone can see integer right here. So say I wanted to store a bunch of variables, just quite literally in this little class right here, I can access them if they're public with the public keyword by typing in the everyone can see. So now I can close that. And you might have noticed that the only this class can see variable actually was not shown up in the autocomplete, which means we cannot access the only this class can see variable because it is private. And I mean, those words are pretty self-explanatory. If you make a variable public by putting the word public before it, it will turn into a variable that everyone can see. And if you make it private, you make it so only this class can see. All right, so let's get into the next modifier, which is here, which is static. And static is kind of funky, and it has strong ties to object-oriented programming, which basically everything in Java has strong ties to object-oriented programming. But for what we need to know and just the scope of this video, static essentially means that if I declare a variable static, I can use it in static methods, and it belongs to this class. And why is that important that I can use it in static methods and it belongs to this class? Well, as you can see, our main method, which is where we run our code, is a static method. So unless I call these variables, which are outside the exact scope of the method, as static, I won't be able to access them within the main method. So that's why we have to declare class variables as static. Okay, so that is static. And now, all right, now this is the quote-unquote meat of the video. So if you zoned out just now, definitely start paying attention. Booleans and if statements. So if you think back to last class, you'll remember that we talked about a primitive type called Boolean. And see if you can recall which two values it can hold. All right, if you got it, it can hold the values of true and false. So it can only hold, well, two values. One returns true and the other one returns false. So how can we use that? Well, a lot of coding is a bunch of doing something called if checking. We're checking, hey, if this certain condition is true, then I want to do this. But if this certain condition is true, I want to do this other thing. And that's just like how life works in general. Say it's raining outside, you want to get a coat. If it's not raining outside, you won't pick up your coat. It's just a bunch of conditionals. So we can represent that in Java through these Booleans. So remember how I was talking about the parameters, like if it's raining, get a coat? Well, you can create a Boolean called is it raining? And you can set it equal to true. And then what you can do is check that Boolean for its value. And if that Boolean does return true, you can do something like print out get a coat. So that is just a basic, I guess, pseudocode overview of how it works. Essentially, you can check the value of a Boolean, and then based on that, do something special. So how do we exactly type that out in code? So I am going to write below here, create a Boolean. I'm going to call it Boolean my bool equals true. So if you remember how variable declaration works, we created a Boolean called my bool and we set it equal to true. So now let's say if my bool is true, I want to get a coat. Oh, why don't I change this name? So I'll change it to is it raining? So is it raining is true. In Seattle, it's going to rain a lot. So we set that to true, and now I will type in these magic words. If is it raining, and then remember the prints from last time, get a coat. So now, make sure I don't have any other prints. Yeah. So now if I run this code, you can see that I've printed out get a coat. So now let's say the next day it stops raining, so it's false. And then I run the code again. Nothing gets printed because, well, there's nothing to print. The if statement, which is what this is right here, this is an if statement. It says if is it raining is true, then do whatever's inside these brackets right here. However, if is it raining is false, you can just go from here to here. Skip whatever's inside. You don't care about that. So that is the basics of an if statement and a single case Boolean. However, that's not necessarily how logic works. It's a much more complicated than that. For example, say it's raining, but it's warm outside. Better example. Say it's rain. There's two Booleans that we can check. It's raining, and it's below 32 degrees Fahrenheit. So let's just assume, putting aside all like the science behind that if it is both raining and it is also below freezing temperature, it is snowing. So how do we check if two things are true back to back? Well, let me make another variable called Boolean is it cold, and I'll set that equal to true. So now we have this if check, right? And we have is it raining, and now I have this new Boolean is it cold. So now I want to have a check. So it has to be both raining and cold for it to be snowing. So what I do is I type in this right here, and. And what that basically means is that if both of these conditions are satisfied, then I am going to say that it is snowing. So I can type in sysout snow exclamation mark. So now if I run this code, it doesn't print anything because is it raining is false. So it'll just be freezing outside, but it's not raining. So there won't be any snow. But then say one day it decides to rain and it's also cold at the same time, then we're going to get snow. But say it's raining one day and it's not snowing. Sorry, it's not cold. Then we won't get any snow. But then again, this falls into the issue that say it's cold outside, so you want to get maybe mittens, but you don't want to wear mittens if it's raining outside, and instead you want to get like your full rain jacket on, right? So there's just a bunch of combinations that we can do with these Booleans, and we can't just make an if check for each one, because say you want to only get a rain jacket on, or sorry, a snow jacket on if it is snowing. But if we did an if check for is it raining and is it cold, and we had another if check for just is it raining, it'll tell you to put on a coat and a snow jacket, because the is it raining is satisfied, but also the is it cold and is it raining is satisfied, which means that it'll be snowing equals coat. But we want to kind of stop there because we don't necessarily care about wearing a rain jacket if it's snowing, right? So what I'm trying to get at here is that we need to add something to this if statement, because we can't just have an if and then skip. So what we have instead is something called an else if statement. So I'm going to put this right here. Basically, an else if says that if this first condition is not satisfied, then check this second condition. And if it too is not satisfied, skip everything. So let's say if it's raining and is it cold, then it's snow, and then we want you to nab a snow jacket. But then else if it's just raining, is it raining? Then what we're going to do is say grab a rain jacket. Now if I run this and I put is it raining to true and is it cold to false, so it's only raining, it's not snowing, it'll say grab a rain jacket. But now if I change is it cold to true, so it is now snowing, so we want to get a snow jacket, it only prints a snow jacket because it says, all right, I satisfied this condition. I don't care what else is there because I found the first truth. So I'm going to skip over the rest of it. So this is pretty useful if you want to do like per se filtering, and you can chain these together. So I can add another else if, and then I can say, oh, is it just cold? Is it cold? And then I can do sysout and I can say get a beanie. So now if I set is it raining to false and is it cold to true, just think to yourself which statement is going to be printed. If you said get a beanie, you'd be correct. That is because it is not raining and cold. So this whole Boolean, think of it as a unit, it's false. Because for the if statement to be satisfied, it needs to be both raining and cold. However, one of those is false. So therefore, the whole thing is false, and it's not going to print. And remember what I said, if the inside of those two parentheses inside of an if statement is false, the if statement won't run. Now it finishes that, says this is false, I'm not going to run the code inside, goes to the next step. Is it raining? Well, it's not raining, it's false, so I'm going to skip that as well. Final check, is it cold? Then what you want to say is, okay, is it cold? What is that? It's true. Awesome. So then I print out get a beanie. But then let's say it's none of those things. It is both not raining and not cold. Well then let's wear some shorts, right? So then I'm going to have an else, but not an else if. This is almost like a last resort kind of thing. Like if all other else ifs and ifs are just returning false, then this else will kick in at the very end. And it will always kick in if all of those other statements were found false. So if any one of the else ifs returned true, it would just quit the whole thing and the else wouldn't run. So now what I'm going to put is out, wear some shorts. So now if I set both of these to false, walk through this in your mind really quickly. Check each of these inside the parentheses and think to yourself whether it's actually going to occur. And now, if I click run, boom, wear some shorts, because all other options were exhausted, and now the only one left was this else statement, which doesn't have an if on it, by the way, so it'll always be like the alternate, the other, and the final option, wear some shorts. And be warned that an else, when you're typing syntactically, it has to be after all the else ifs. You can't have an else and then an else if afterwards, because that makes no sense, because the else is going to kick in, and then why would you need another else if afterwards? And Java just won't let you do that. All right, awesome. So now that we've gotten into like how if statements work and just like the basics of like how to structure them, let's back up a bit. I'm going to delete that. So let's think about the is it raining and is it cold? That is something called an and operator. That's what the two and symbols are. And you have to have two, by the way. So what about if it's raining or it's cold and you don't like either of those weathers? So you want to stay inside if it's raining or cold. Well, you can't do the and symbol because both conditions need to be satisfied for you to hate the weather, because you hate cold and rain, right? So what we can put instead of the and symbol is these two pipe characters, which actually when I first started learning code, it actually took forever for me to find these. It's right underneath the backspace button for me, and it's above the backslash. So if you press shift and then the backslash key, you'll get these pipe characters. And what this says is that if it's either raining or cold or both, then I'll change the inside thing. Stay inside. So now let's check here. We have both of them set to false, right? So if I run this, nothing will happen because is it raining? Is it cold? That's false. That's false. Neither of them are true. Therefore, we return false to the whole statement, and it skips over the if. But if I change is it raining to true, then I want to stay inside. But then say I also change is it cold to true, then I'm also going to stay inside. And finally, say I change is it raining to false, so only the other one is true now. Still going to stay inside because that's how the or operator works. Okay, now we've gone over ands and ors. Oh, quick thing. I'm going to kind of put it all together here. So I'm going to say if it's raining or it's cold, stay inside. And I'm going to have an else statement saying go outside. So now, what do you think will happen if I run the code as it is right now? Will it print stay inside or go outside? And think to yourself, what is the change I need to make it say go outside if it says stay inside? All right, let's check it out. It says stay inside because one of these two Booleans return true. Therefore, the whole condition is satisfied. It did the if statement and then exited the whole thing. And it said stay inside, and then it didn't feel the need to check this else because it's an else, right? This condition is satisfied, so it can just run this and then leave. But if I change both of these to false, then what happens? It told me to go outside because it's not raining, it's not cold, so why don't we head outside? Okay, awesome. So yeah, you guys can type that out. Feel free to mess with it. And one last thing that's very important for if checks. And this is a bit more of like a interesting concept, and it might make you want to, bang your head against a wall sometimes, but trust me, it's worth learning. So I just added an exclamation mark. So what does that mean? It basically means the Boolean attached to the exclamation mark, whatever it is, flip it. That's just essentially what it is. And if you'll most often hear it like spoken in English, not or bang. So if I say not is it raining or it's cold outside, it kind of messes with your head. But what this basically says is think of is it raining and is it cold outside, right? So if is it cold outside returns true, then this whole thing will return true because you only need one of the things to return true. But let's say is it cold is false, okay? Is it cold is false. Now, is it raining? If I put is it raining to false, this exclamation mark will switch it to true. So even though both conditions are false, it'll still tell me to stay inside because what happens is what the machine does, it says, okay, is it raining equals false, right? So why don't I turn this to false? And then exclamation mark false means true. So true. And then is it cold is false, right? So false. But all I need is one true for this whole thing to be true, right? So then I just print out stay inside, which is what happened. So that is the power of the exclamation mark or bang. Basically, it takes whatever it is, whatever the Boolean it is attached to, and turns it opposite. And when you start coding more complex logic expressions, you're gonna see a bunch of parentheses maybe. So how to deal with these is essentially treat every single parentheses as a unit. So calculate whatever's inside, and then treat that as a single Boolean, and then apply it to everything else. Like for example, let's say I have this right here. Let's say I have x and y. Pretend these are all Booleans, by the way, or z, right? So now it might look complicating at first, like, oh, which one do I do the or to the y and the z, or do I do the x and the y? What you're going to do is look at the most internal set of parentheses and say, okay, let's just treat this section as its own block, x and y, and then check the variables and then make sure that the values match up to return true or false if you want to return false. Say x is true and y is false. So this whole block you can rewrite as simply false because both needed to be true in order to satisfy the true. But they weren't. So now you can return false. But then let's say z is true. False or true. Well, it's an or statement, so only one of them needs to be true. Therefore, this whole expression is true for the cases I said, with one of the x and the y being true and false, and then the z being true. So that's how you can simplify Boolean expressions. It's pretty fun, and this is really useful because you're gonna find yourself as you get better and better at coding, just making a ton of like Booleans and variables, etc., and then you'll be confusing yourself because you'll make this if statement and it just won't work the way you want it to. You really need to be able to deconstruct it and figure out, oh, I should have put parentheses here, and I should have put the exclamation mark here, and I should have put like this and symbol here. So that is if-else statements. Okay, so now I'm going to direct you guys to some practice problems with Booleans. So what we just did with like taking the x, the y, and the z, kind of deconstructing it based on the values I give x, y, and z, and finding a final result for that Boolean expression. You can find that on the GitHub. I made this little markdown file with all the questions on it. You can pull it up there. I have the GitHub link down in the description of the YouTube video. Feel free to click on that. It's basically just this little stylized page full of questions, and it has an example on it, so you guys can work through that, answer all of them. You can see them here as well, and then there's like this little thing at the bottom that tells you to check all of them and do a little change for each of them. And at the end you should have two things. 5 answers which are either true or false, and then another 5 answers that tell me about which variable I should switch to switch the ultimate expression of the Boolean. It's all in there. I'd go check that out right now, pause the video, solve those problems, and then when you want to, click on the answers folder, which is also in the GitHub, and check that out. I'm not going to click on it because I don't want to show you guys, but please do the problems first before checking the answers. And if you're confused on any of them, immediately send me a message and I'll explain to you why it's one way or the other. But yeah, those are the practice problems. So I can give you a second, pause the video here, go try them out.